So the next one is trapezoidal rule. We have the same integral problem, but we are going to use trapezoidal rule. Trapezoidal rule is also listed here in the table. In this also, first step is to find delta x. That's exactly same. I'm going to repeat it one more time. B minus A. A is the lower limit in this integral is 1. B is the upper limit, which is 2. And n is given as 4. So b minus a is 2 minus 1 by 4. That will be 1 by 4. So how you see it is on the number line, you can plot the lower limit and upper limit. That portion you need to divide into 4 equal portions. The first one is x naught, the last one is x4. Then we have x1, x2, and x3. You find x1 by adding delta x. This much is delta x. All these are delta x, which is 1 by 4. So 1 plus 1 by 4, this is going to be 5 by 4. 5 by 4 plus 1 by 4, this is going to be 3 by 2. 3 by 2 plus 1 by 4, this is going to be 7 by 4. You can use calculators to add these. So basically what I'm saying here is that we have x naught is 1, x1 is 5 by 4, x2 is 3 by 2, x3 is 7 by 4, and x4 is the last number 2. Now, according to trapezoidal rule, our integral, in this case, again, the function is same, right? So f of x is 1 by x. So what do we have? Please note, it's f of x naught. First is divided by 2 and the last is also divided by 2. Okay. Delta x is outside, you see. The first and the last are divided by 2 and in between all function values are just whole, not divided by 2. Okay, let's see. What do we have? F of x naught. X naught is 1. F of x naught will be 1 by 1. And we have half with it. Plus f of x1. F of x is 1 by x and x1 is 5 by 4. Plus 1 by x2. x2 is 3 by 2. Plus 1 by 7 by 4. Plus half of f of x4, which is 1 by 2. And delta x here is 1 by 4. So what we have is 1 by 2. Reciprocal of 5 by 4 is 4 by 5 plus 2 by 3 plus 4 by 7 plus 1 by 4 and multiply all that by 1 by 4. You can punch all this in the calculator and get a decimal value. I'm getting 0.697, 0 as close approximation. So that's pretty close to the midpoint one also, but these are just different ways of approximating integral based on our question. So let's work on the last one is Simpson's rule. The Simpson's rules also use same x0, x1 values, so I kept them same as the trapezoidal rule. No need to change. It's the same method. Find delta x. On the number line, write 1 and 2, split 4 equal parts, and then keep adding 1 by 4th to get the next x0 value, x1 value, right? But in Simpson's rule approximation for this integral, notice here, this is Simpson rule. The first one is just f of x naught, okay, plus the last one is also just f of xn. In this case, n is 4, so x4. Outside we have delta x by 3, but the middle terms are multiples of 4 to alternating. So 4 times f of x1 plus 2 times f of x2 plus 4 times f of x3. That's just a reminding trick for this. F of x, our question is 1 by x, if you notice. So we can use that. X naught is 1. So 1 by 1 plus 4 times 1 by 5 by 4 plus 2 times 1 by x2, which is 3 by 2, plus 4 times 1 by 7 by 4, plus f of x4, which is just 1 by 2, times delta x. What is delta x again? 1 by 4 by 3. Let's write it one more time. This is 1. 4 times 4 by 5 plus 2 times 2 by 3 plus 4 times 4 by 7 plus half. 1 by 4 by 3 is 1 by 12. You can punch all it in the calculator. I'm getting 0.6932. So this is an approximation for Simpson's rule. Approximation of the integral using the Simpson rule.